All information is provided under the safe harbor statement you see on the screen. I will give you a moment to read that. Today's event, a fireside chat on the future of the data center, will be moderated by Patrick Moorhead, Chief Analyst at More Insights and Strategy. He'll be joined by Jeremy Werner, Corporate Vice President and General Manager of Micron's Storage Business Unit, along with Raj Hazra, Senior Vice President and General Manager of Micron's Compute and Networking Business Unit. After the conclusion of the presentation, we'll provide an opportunity for Q&A. To ask questions, you may use the Raise My Hand feature, and I'll call on you to ask your question directly. And now I'll turn it over to Patrick.
Thank you very much. The first thing I'd like to do is thank the audience for tuning in. I think we have some really good conversations here, and we are here to talk about the future of the data center. Provocative, I know, and I could start off showing all the slides we always see with the explosion of data, the fact that we create more data in a day than we used to in weeks, months, or years. But I won't. I'm going to just jump right into it and welcome Raj and Jeremy. How are you?
I'm good. Thank you. Good morning and good afternoon to folks, wherever you are. Thanks for tuning in, and I'm looking forward to this conversation. I mean, this is one of the moments in time when we're going to look back at this moment, maybe 10, 15 years from now, and say, man, it was like landing on the moon.
Hey, Pat, good morning. Great to be here with you and the audience today.
Yeah. So, hey, you two are rock stars in the industry already, but maybe there's some people who are unfamiliar with you. Maybe you can talk about what do both of you do for Micron?
Well, maybe I'll go first then. I don't know about the rock star part, but I have the tremendous privilege of leading our compute and networking business, which really is foundational memory technologies, creating them and shipping them to our customers for today while we work on creating the possibilities for tomorrow. So it's an innovation engine, it's a passion, and it's a calling for me, and I couldn't be happier at this point in time.
I'm Jeremy Werner. I'm the General Manager of the Storage Business Unit. Storage Business Unit at Micron, we manage all of the NAND-based products that go into kind of compute applications typically. So whether it's a notebook or a desktop, servers, storage, that can be SSDs, components, basically anything that has NAND for computer storage.
Excellent. So let's get started here. I always like to start off a little bit provocatively to get people's blood going here. And, we're talking about the future of the data center, but isn't that really driven by processors? Isn't that what we've been programmed to think for the last 30 years? Jeremy, maybe we'll start with you.
Well, I mean, there's no doubt that processors are an important part of the data center, but without access to data, really processors can't do anything. And if you look at what's been happening, we're living at an unprecedented time in human history in terms of the way that we collect data, generate data, the way that we interact and use that data to really solve problems for mankind. I mean, recently, you saw creation of a vaccine for the pandemic in a very short amount of time. These types of problems that we're trying to solve are enormous. And the types of leaps forward that we're making, for instance, let's say autonomous driving, all rely on massive amounts of data being analyzed very rapidly. There was a study recently about the growth of IoT, and it's growing at 50% a year. And these are all kinds of things, from doorbells to cameras, cars, phones, et cetera, that are just feeding an enormous growth in the data center. And being able to manage, access, and really utilize this data in a productive way for both businesses and consumers is a major trend that's shaping everything that happens in the data center.
Yeah, to Jeremy's point, I mean, generating insights from information. We talk a lot about data, but data is a means to an end, and that end is insight, either a business insight or a science insight, a value delivered out of data. Generating that insight, Pat, is a cooperative work between compute, memory, storage, and networking. You have to store the data, you have to move the data, and then you have to crunch on the data. And so when we say, the generations of data centers of the future are going to have to deal with this massive influx of data that Jeremy just talked about, we're talking about these three things working in tandem. While a lot of it has been partly the focus in the past has been on the compute side, partly in some ways because the compute challenges of delivering ever increasing, whether it's flops per watt or tops per watt now, depending on what kind of workload you look at, have been daunting, all the way from terascale to petascale to exascale and maybe even beyond. No one has really focused on as hard as we have now on what needs to keep up in memory and storage to continue to enable that insight generation in an effective manner and efficient manner. And that's why, as we look at the challenges to this tremendous explosion of data, and not only generating insights, but generating them more accurately, more quickly, and getting the value out of it kind of in an instantaneous form, we have to look at sea changes in the way memory and storage is constructed in the platform, which is why it's the center of attention right now.
Yeah, guys, I've had a lot of different careers, probably a different one every decade, whether it's, systems for a decade, processors for another decade, and analyzing industry. I did do a stint where I managed the nation's largest x86 data center as well. And I'll have to say, what I see now more than ever is that memory and storage are helping to drive that next generation. So, hey, hopefully we've established why Micron and the entire memory and storage industry has permission to talk about the future of the data center. Because quite frankly, it doesn't happen without you. So let's narrow in on the here and now of the data center. What are some of the bigger challenges in today's data center? Because everything's not perfect there either. We're making advancements, but we still have a ways to go. And by the way, those challenges today give us a little bit of insight in what we're going to do tomorrow, which I know we're going to talk about a little bit toward the end of the show.
The biggest thing about the data center is today it's literally drowning under data. As user demands for the data to be stored, to be used, as I said previously, for insight, and the rate at which this data is being generated is unforeseen, right? The thing though is data centers don't have the luxury of saying, I just get bigger with bigger muscles and run the same application with more data. They have to deal with a plethora of workloads, very diverse in their characteristics on compute, memory, storage, and even the networking pieces. So the first challenge is they have to continue to provide that effective performance per watt, performance per TCO at a time when algorithms are becoming more demanding, more data, and frankly, customers are expecting more. Right, so that's the heart of why we will continue at an unabated pace to get to data centers. So the biggest challenge is, how do you, in a balanced way, take forward the algorithm enhancement and make it feasible? 60, 70 years ago, when the discrete Fourier transform was realized into practice on compute, people said, here's a mathematical tool that can now actually do things, like video compression or image compression. And then it became part and parcel of, the smallest chip or microcontroller that you can find today, right? That's the progression we are on as computing, memory, and storage moves forward. In, again, that scalable performance per TCO, as well as increasing levels of capability delivered through the combination of hardware and software advances.
And I think to just add to Raj's view of some of the challenges that are faced, if we kind of zoom out to the 50,000 foot level, we see a number of societal challenges that are actually mirrored in the data center industry. So, for instance, security. Everyone, you read about it all the time. This hack, someone has hijacked someone's data, they're blackmailing them. These are real issues. And as people move to the cloud and put their data in another company's equipment, security is vital. We see it all the time. Privacy is super important to everyone. And securing people's data both at rest and in flight is something that really data centers have addressed, but there's still more work that I think needs to be done as an industry. Another example that we face is climate change and just simple access to energy. These data centers are huge and they're being built all around the world. So if we look at what those data centers need to do to scale, to provide support for the desires of humanity to have everything instantly at their fingertips. We need more data centers. We need them located all around the world. Everything has to be redundant, and all of this takes a lot of power. So how do we continue to meet the demands of society, the expectations that everyone has from modern applications, from social media to search to access to streaming media? How do we deliver that in a way that meets the expectations of society, but also preserves our planet, also is cost effective, and allows us to scale as rapidly as everyone desires?
You guys did a great job painting where we are right now. It kind of reinforced in my head. It's like, I can't believe some of the tech industry, we just don't pack up and give up. It's almost like the Kobayashi Maru. It's like, hey, the end customers, they want it now. They want more. It has to be secure, yet the data is in more places than it's ever been. Oh, by the way, and do it with less energy and make it cheaper, all that at once. So that's the setup here for today. So with that in mind, Jeremy and Raj, what are you doing today to help solve these types of challenges in today's data center?
Right. Well, obviously, that's part of the reason we're here today is we are announcing, and I'm very excited to announce that Micron is releasing our first Gen 4 data center NVMe SSD. This is a really exciting development for us. It's a fully vertically integrated product. So we developed the memory, we developed the DRAM, the controller, as well as all the firmware. And the amazing thing about this product is it's bringing so much flexibility to our customers. It actually has the world's broadest portfolio of form factors, which is really critical because we are at this nexus right now in the data center where there's a lot of legacy systems, and now we're moving to more flash optimized systems. And part of what we've released today is 3 different EDSFF form factors, which really represent the next generation custom designed form factor to enable flash in the data center in an optimized fashion. In the past, of course, hard drives were huge for data centers, and they continue to be used heavily for colder data. But as flash has become more affordable, a lot of the hard drive applications have moved to flash. And now really most of the compute and the high performance applications rely on flash in the data center. And with that, optimizing the form factors for flash allows better performance, reduction of the footprint in the data center, reduction in energy consumption. In fact, these products deliver almost 1 million IOPS in just 6 watts, which is over double the amount of performance per watt that we had in our Gen 3 generation of NVMe SSDs. So just really excited about that. Also, another thing that we're announcing today to help people to better use heterogeneous memory and storage implementations in their systems is our heterogeneous memory storage engine, we like to call HSE 2.0. It's actually an open source product that we have made available to everyone, and it allows people or data centers really to very efficiently use data and place it in different ways for different accessibility to really optimize around performance, cost, and data availability. So please go to micron.com/HSE for more information on that.
Well, hey, thank you for inviting me to the party. I may have known something about it beforehand, but congratulations. And it's funny, my response to, oh my gosh, so many form factors is, listen, there is the idea of a homogeneous data center is the past, right? We have scale up, we have scale out, we have edge of data center, we have the inside of data center, we have different optimization levels for storage and heat and cooling. So bring it on. I'm sure from a supply chain standpoint, it makes it makes it a little bit more complex, but you have to give the customers what they want and allow them to optimize for certain use cases. And Raj, I know you haven't been standing still as of late either.
Yeah, not at all, not at all. Although I'm thrilled, and congratulations to Jeremy and the entire team. It's fabulous to see, as you said. Even though it sounds like different strokes for different folks, it's really different solutions for different folks, and it's just it's amazing to see technology delivered into the hands of our customers. So congrats once again. On the memory side, absolutely, no time to stand still as that that wave moves forward, right? So as you know, in the silicon business, everything starts with best-in-class silicon technology, and frankly, this is something we worked at very hard, Pat, over the last, several years, some would say even decades. And Micron's now at a point where we're leading in the fundamental underlying technology nodes for both DRAM and NAND at this point in time. And that's really the heart of building great products, is if you have leadership underlying silicon technology and then high volume manufacturing to take products, to create products and take it out to the market. So as part of our lead, as we previously announced, we are on our 1 alpha nanometer node ahead of the rest of the industry and developing and shipping, frankly, in volume, the DDR4, the product set, widely qualified across the market, whether you look at it as the cloud service providers, enterprise customers, client, just ramping superbly, bringing that leading edge silicon technology value to our customers. You'll find it ramping across the board on all the major CPU platforms, Ice Lake from Intel, Milan from AMD, and there's a few other entrants in that marketplace too, but they all rely and want that leadership technology and the products based on that. Very proud of that. And as we build 4, 5 comes right behind. I mean, DDR5 is a game changer in terms of direct attached memory for the data center, right? Built grounds up for the data center, I would say, with all the capabilities built in that looks at where memory, direct attached memory, is going to play in the data center, up to thinking about, higher, not just higher speeds, but higher bus efficiency, higher capacities being standardized through JEDEC to understand the need for higher capacity near attached memory, architectural innovations to get to 2x bandwidth, 2x effective use of the bus, frankly, improved RAS as the scale at which these solutions are going to be deployed in the data center. Lower power, frankly, recognizing that it's not 100,000 or few, you have millions of these pieces and soon to be tens and hundreds, if not 1,000, trillions of these in a hyperscale data center, built with that in mind and lower power from use of lower voltage. So, it's just stunning that the world never stops still. And we are very proud that we are the cause of it. So that's the other thing we've been working on. We are qualifying it with our customers, as the market moves, first client and then server customers. We see tremendous pent-up demand for the capabilities of DDR5, particularly as a sign of how critical memory is in unlocking that promise of the future of the data center. And that transformation really starts with the first DDR generation of products built specifically for the data center in mind, and that's DDR5.
Yeah, so Raj, you have been busy. It is incredible. And I see this next generation of innovations for the future, the next generation of data center, bigger than ever related to memory. I mean, if you look at the notion of disaggregated, composable memory, that resets the way that we look at it, right? We've been able to disaggregate storage and to some element even networking in the way that we're adding a bunch of compute and memory to the networking layer, and to be able to even compose that. But all during this time, it was always processor and memory were inextricably linked. They had to be really, really close together for any type of speed. We had different ways like Rocky and things like that to be able to make it, in scale environments look like it was a one planar memory, but it always came with downsides, right? You needed more memory, you got to buy more compute, right? Every single time. Great for the processor folks, but if all you needed was more memory to do something different, not exactly optimal for a new architecture of the data center. And with HBM, with Moore's law, basically, slowing down and putting the onus of the industry on accelerators more and more than ever. And whether that's a GPU, a fixed function, ASIC, or any type of accelerator out there, tying that together with HBM is just, it's going to be a thing out there in the future. So big changes. So Jeremy, are you going to one up the future here with what Raj is doing? Have you been so focused on getting this 7400 out that you put the future on hold?
Well, of course, you can never put the future on hold. And in fact, right now we're planning and working on products that we're talking about releasing 5-6 years from now. And really, it's amazing how much planning and how much work through the entire ecosystem goes into releasing and bringing these products to market and being able to have them rapidly adopted and used. We work extensively with companies across the ecosystem, from processor vendors to network providers, in order to ensure that our products are compatible when we release them. And that silicon design cycle, software design cycle, integration, it's very long. So we are looking way out into the future. And another big part of that is the work that we do with this standardization of products, which is very important to allow a robust global ecosystem. We talked a little bit already about EDSFF and the fact that that's a new standard form factor. Another thing that is interesting in the 7400 that we're releasing is it's the first product that actually supports the OCP standard, which is the Open Compute Defined NVMe SSD requirements for qualified applications. And this is an important development because many of the NVMe SSDs in the market today kind of have disjointed features and not necessarily great compatibility, interchangeability. The introduction of the OCP standard will help to address that. But even within that, there's still a lot of work to be done. So one of the areas that Micron has actually been leading the industry in terms of flash is with our 4-bit per cell, oftentimes referred to as QLC technology. And the great thing about QLC is it reduces the cost of flash, which is what everyone wants. We're on this kind of constant treadmill of cost reductions with flash. And QLC, it's an amazing technology, but it does bring new challenges to the devices in order to adopt it. And one of the things that we've been working on with customers for planning that adoption of our QLC technology is something called ZNS, or zone namespace, which allows the host to use QLC technology in a way that is friendly and to accelerate the adoption and the cost reduction for the entire industry. So that's an interesting trend. And then, you talked a little bit about disaggregation, and in general, data centers, IT infrastructure, they've kind of gone back and forth over the years. If you look at composability, and really what's happening in the cloud orchestration, it's like a giant game of Tetris. I don't know if anyone plays Tetris anymore, but I think we played Tetris growing up. But it is a giant game of Tetris. And how do you move applications around the data center to make them most efficient in terms of utilizing that hardware? And when we look at that game, NVMe over Fabric, which is a technology which has been introduced but not really fully adopted, is going to provide the type of performance that applications are able to get today with direct attached flash storage or SSDs, but in a way that pulls them out, makes access across the data center better, makes it more efficient, and makes that Tetris game a lot easier, because now you can dynamically allocate resources in a more flexible manner. And then, you heard what Raj was talking about earlier. I think this is the amazing power of CXL, because if you look at that orchestration that's been happening, compute, relatively clear. We have virtualization, we have containers, we know how to chop up a processor into many small pieces. Storage, we have NVMe over Fabric, we have distributed file systems, software-defined storage. What about memory? It's been a problem. And, that's why I want to kick it back to Raj to really kind of emphasize how CXL and what we're doing at Micron is going to be a game changer for really getting us to level 2000 on that Tetris game.
Yeah, thanks, Jeremy. As you were speaking, I was like, I wish I could reach out and just pump you on the shoulder. Pat, as you know, some of you know, I've been a compute guy for nearly 25 years, quarter of a century. And I've looked at the inside problem from the side of compute. And, it's so exciting now to say memory is going places, right? And you could think of that as me saying, well, of course, memory is going places because it's highly in demand and Micron's doing well. But memory is really going places in the platform and in the system. Right? No longer is it just pump in more capacity, more bandwidth, more channels, more ranks to get reasonable but still incremental performance over that same paradigm of DDR2, 3, 4, 5, as interesting as they are. When memory is going places reminds me, of decades ago when computing went from single core to multi-core. Right? Suddenly we broke through this barrier of having to shove more frequency, play with voltage, and deliver more instructions per clock. To, my God, we can scale things out. We can put them in different places. We can balance the workload. That's really what's happening. That is the significance of a technology like CXL. That is the fundamental underpinning of how you make memory go places for the benefit of workloads and customers who are using that workload. For the first time, the words memory hierarchy, just like in compute it was, single to parallel or serial to parallel, is true. With CXL, you can have a view of a single system with a memory and storage hierarchy, and you can have a view of a distributed system like a hyperscale data center, an orchestrated data center, as Jeremy was talking about. You can have a view of that as having a hierarchy and pools. Right? And that is the fundamental inflection point, the ability to take the free up memory from having to be directly attached to compute and go places and define a new level of system architectures to take advantage of these characteristics. That's the promise of CXL. And if you are a memory guy or a storage guy, I don't care which one you are, you've got to say, thank God I'm here at this point in time to be part of that journey.
I'll tell you what, I think we're in the mutual agreement club here. If you recall early on, the disaggregation of memory and, the increased composability and disaggregation of storage will fundamentally change the way that the largest hyperscalers are architecting their data centers. And then after that, it'll be the on-prem folks. Jeremy, related to some of the innovations that you're working on, I can tell you from firsthand, they're super excited to have best of both worlds, NVMe over Fabric, kind of this HCI. It used to be HCI versus converged infrastructure, right? And how do I, which one do I go with? Hey, I love the simplicity of HCI. I talked to a bank recently. They have 75,000 HCI nodes, and they explained it to me that it's growing like kudzu, out of control. Right, it's just out of control. I need to bring it back. And hey, do I do converged? Do I do more HCI? What do I do now? And from NDA discussions with some of your customers on ZNS, they're super excited about that as well. So we've talked about memory and storage being a driver of the future architecture of the data center. We talked about Jeremy's big announcement, the 7400 line, and Raj, while he's not announcing something new today, has had a lot of announcements, particularly in support of some of the new processors from AMD and Intel and even ARM. But let's get down to how this actually comes together. Like I said, my experience, 10, 10, 10. I'm always amazed that a new platform shows up with a new memory hierarchy, potentially a new storage technology, and it works on day one, even though everything is changing up to the last minute, right? And I'm curious, how do you drive all of these new innovations working with the ecosystem? It really does take a village, and maybe we'll start off with Raj on this one.
You're absolutely right. As Alan Kay had once said, you don't sit here waiting for the future to be created. You create it, and if the future is 5 years out, as Jeremy said, we start working on it. We're working on things that we think could be viable in the next 10 years, but we think we're already late. So it's with that sense of urgency you start. You work with your customers to understand, what is it that are the principal problems, not even what their requirements are, because some of our customers and partners in the ecosystem still haven't quite nailed down what the specific problems are. So we're not sitting there with a notepad taking notes on, and please do this, this, and this. It's a journey of discovery for partners as we look at what are the fundamental opportunities that we could unlock. If you could work X, Y, and Z a little bit better, or if you could change P and Q in the platform. So that starts with a very, very closely tied, trusting relationship with customers and partners in the ecosystem who are going to be, at the end of the day, part of the solution. The second is diligently working at it, failing fast if we have to, and continuously correcting to stay focused on, is the value proposition still viable, and bringing together all elements of the ecosystem on that journey. When I was talking that's very true in big efforts like CXL, where the hardware ecosystem and in the entire software ecosystem has to work as one quote unquote a company to deliver all the pieces that have to be orchestrated together, have to work together, have to be optimized together. But it's also true in things that aren't as big as expensive as CXL, like DDR5, where we started the technology enabling program to say, let's make sure if there are any barriers in know-how, in validation, in functional testing, in specs, in just part, sometimes even competitors talking to each other about how some of these technologies are going to be interpreted so there's not an interoperability issue, let's go do that. And so we took charge of that and led with the technology enabling program for DDR5. At the end of the day, it really comes down to working with the ecosystem, working very closely with your customers, staying focused on value propositions, learning and failing fast if you have to, but never taking your eyes off the ball.
Yeah. So, gosh, Jeremy, from your point of view, you just plug into an interface and you call it a day, right? Standard interface. So you're done.
Yeah, pretty much. I'm going to go home now. So in all seriousness, I mean, we talked about some of the standardization work that we've done, but another thing that we didn't really get to talk too much about was how we work with the software ecosystem. So I talked about the HSE open source platform. We also work with a number of private solutions. So for instance, we work extensively with VMware, with partners like WEC.io and Lightbit Labs that are enabling the integration and use of new features in a timely manner. And a big part of the software ecosystem also is around introducing security to the data center. So solutions like enterprise key management solutions from partners that we have like WinMagic are very important pieces. And we've been working with standards bodies to define and deliver a standard interface like TCG, IEEE 1667. Sometimes people refer to the combination of those as eDrive. But with security, it's not just the standardization of the interface. Implementation matters. And what I mean by that is, imagine your front door very securely locked. You've got the bar, nobody can kick it down. It's a nice thick door. Your lock is very secure, can't be picked. Oh, but by the way, there's an open window right next door to it, right? So, that would be an example of a bad security implementation. And that's why in the 7400 that we're introducing today, we have a new development in addition to delivering TCG, in addition to getting FIPS certification. We have something that we're calling the secure execution environment. And it's, as far as I know, unique in the industry in that we're delivering a trusted hardware, dedicated security execution environment with dedicated RAM and secure firmware in order to run the critical security functions inside the drive. And we believe that that is a unique differentiator as well for us in terms of, yes, do other people's doors lock? Absolutely. But by the way, our windows closed.
Jeremy, you're just knocking out of the park here with the analogies. This is really good. The open door, and I like that. I'm going to have to do a little bit more research on your secure execution environment for sure. But no, it definitely takes a village, and I appreciate you explaining all that. So like all my discussions here online, I always like to give my guests the ability to share anything maybe they didn't talk about, or maybe you expected me to ask you a question that I didn't ask you. You don't have to say anything if you don't want to, but I wanted to give you the last word.
Sure. So obviously so excited about this product launch. We talked a lot about EDSFF. There's some other things that we're doing with this launch. We also support U.3, which is a great form factor for enabling flexibility in sockets between SATA, SAS, and NVMe in a socket. Of course, we're plugging NVMe in, but we also have SATA SSDs that some people prefer. And that's an enabling form factor. We're also, with this product, supporting down to 400 gigabyte capacity points on a 2280 M.2 with power loss protection, which is just a fantastic product for boot and logging in data centers. Not a lot of our competitors offer kind of the broad range of product that we're offering them, and supporting that M.2 and multiple M.2 form factors, supporting the various thicknesses of the E1S, supporting both 7 and 15 millimeter, 2.5 inch form factors, the wide range of capacities from 512, 400, all the way up to 8 terabyte. Just really going to address a broad range of needs in our customer base. And I think all I can say is, stay tuned. This is just the first of a number of very exciting announcements you're going to see from Micron over the course of the next year, particularly focused on the data center. So, and I also want to thank you, Pat, because, being able to talk to you, great experience, your reputation precedes you in the industry, and really appreciate your time today. So thank you.
Jeremy, thank you.
I want to say again, thanks, Pat. It's good to see you again and talk about this. As you can clearly see, I'm very passionate about this. What is this I'm talking about? I'm talking about the golden age of memory. People talk about the golden age of data, but it really is the golden age of memory and storage. And particularly in memory, I think the time has arrived, and it is our calling as Micron to completely bust through some of the older paradigms of what memory meant, which is attached to compute, to driving the central thematic structures of how data movement, data intensive computing is done. And I think what I am seeing and what we are working on is a frenetic pace of innovation, which, as Justin Trudeau said, I think it's never been this fast before, and it's never going to be as slow again. So I think now with that balance of memory and storage and compute and networking working in one system concept across hardware and software, we are now getting to a rate and pace of innovation, which, as I said, as we started this conversation, 5 years from now, we'll look back at our current data centers and say, my God, and our lives still ran, right? It's really that exciting. And for many of us, it's a once in a lifetime kind of opportunity to be associated, helping, and benefiting from it as citizens. So once again, thank you for this great conversation. Certainly, it's put a little bit of a zip in my heart rate for the rest of the day. I hope it has for you and the viewers as well. All the best, and thanks again for the opportunity to have this chat.
Raj, that was a super motivating close and also very realistic, given what memory technologies are going to bring to customers and solving some of our biggest problems out there on the planet.